Ready? Could you tell me about what you've put together?
Yeah, so our project is named the West Slope Landscape. So it's basically a simulation program simulating the growth of procedurally generated trees on the west slope of Cornell. It has a few components. First, there is a manually drawn slope and the tower itself. And of course, there are trees growing in the middle. And on the upper left, you can see there is a microphone component, just collecting the sound inputs from the environment. And that is going to be used to control the speed of how fast trees are growing.
Okay.
And I'll go ahead and explain how it works.
Sure.
So the tree on the left and on the right, those are Barnsley-Fern systems. So basically it's a mathematical procedure of randomly applying linear transformations to points and use that to generate the shape of leaves. And after hundreds or thousands of iterations, some points are going to become part of the leaves and some points are going to become part of the stem, and they'll collectively construct the shape of a tree. And the one in the middle is called the L system, and how it works is that you design a base string and a set of rules of how that string can grow upon itself. And also after a few iterations, it is gonna generate a product string that we use to describe the structure of the tree. And I think it's a pretty interesting system because it can not only be used to describe the shape of trees, but also a lot of other fractal systems that we found in nature. Say like snowflakes.
Okay.
But that requires a very different design of the strings and the set of rules. So we're only using the one that works for trees. And the other part is the microphone. So we have this little sensor on the board. It's collecting the sound inputs from the environment, and we apply some signal processing techniques such as like intensity thresholding and moving average buffers, just to cancel out the noise and avoid like drastic changes in input signals. And that what are we expecting is that if we play some sort of music as the tree grows, we will see that the trees are growing at different speed as the music progresses.
Okay.
We can say that now, if we don't input music to the microphone, the tree will just growing in a very slow speed. But we can wait for another iteration, and then we just input music to the microphone.
Okay.
Like, you can see that the trees will just grow faster. Yeah, and we don't input that music, and then the speed.
And then it gets slow again.
Yeah, slow.
That's gorgeous.
And we want that to grow faster, but just input music again. And here we have the frequency of the music.
Is the L system different every time? Is it randomized?
Yeah, we put some random C's.
Are a few sets of rules that we include.
Like the length of each line is different, and the size and the structure. We have like three structure of the trees, three mainly structures.
And so there are like a few parameters that we try and randomize for each model, but we also pick random models.
And I'm trying to think of how to ask this. So do you compute the whole tree structure, the Barnsley fern of the L system first, and then render it slowly? Or is it rendered and computed? Or is it rendered as it's computed, or is the whole structure computed and then rendered?
For the Barnsley fern, I think we just compute each pairs of leaves and use it as a model, and then for each iteration, we just scale these points in a different.
Okay. Okay.
Yeah. And for the L system, for each tree, we have a very long string that will determine what will be the shape of the whole tree. We just generate that string in the beginning of the tree.
Okay. Okay. And then the rate at which you move through that string and render it is decided by the microphone input.
Yeah.
Yes.
I see. Boy, it's really easy to just sit here and watch it. It's very pretty.
It's a lot of variations.
Very, very nice. And I'm noticing that the shape of the Barnsley fern generated trees varies slightly from iteration to iteration as well. So you must be modifying some parameters that describe the Barnsley fern generation, correct?
Yes, we are modifying some parameters in the linear transformation functions,
Yeah.
Okay.
so that it just generates some leaves are sharper, some leaves are wrong. And,
Yes.
Yeah.
Very nice. Thank you all. It's really, really nice.
Thank you.